Good morning, students. Welcome back to this software engineering class again. In the last class, we have discussed about architecture design. Okay, so we are passing on to the next unit of our syllabus. The next unit is comprising of planning a software project and a detailed design. Planning a software project and a detailed design, and it is a very important unit. Okay. So let us start with planning a software project. See, when you take a very big task or a complex task, you always do proper planning. Okay. So when you choose your course for your study, before choosing your course, you must have planned for like whether this course is viable for me. Can I improve myself in this course? Or do you do various planning? Like that when you invest some money in a particular venture, before investing you do a lot of planning. No one will do any bigger task without any proper planning. If they do without any proper planning, then they will end up miserably with failures. Okay, so yeah, planning is a must for any bigger task. Okay, so the project management activities of a software project can be viewed as a can be viewed as having three major phases, namely uh, project planning phase, then project monitoring and control phase, then the next phase, the last one is project termination phase. Okay, so in the software development, there are at least three phases, namely project planning, project monitoring and control, and project termination. So among these things, planning may be the most important management activity of all these three. Okay. So without a proper project plan, failure of the project is very much possible. Okay. So in software project planning, what are the activities that we address? Okay. What are the various activities that we address? We address about process planning, we address about effort estimation, we address about scheduling and resource estimation, we plan for quality plans, we plan for configuration management, we plan for risk management, we plan for project monitoring. All these things are taken into account when you do a project planning. In this chapter, we will discuss all these activities: how to do process planning, how to plan for effort estimation, how to plan for scheduling and resource. Like this, all these activities are planned in this chapter that we will see one by one. So let us start with process planning. Okay, for a project during planning, for a project during planning, a key activity is to plan and specify the process that should be used in the project. Okay. See, I told you well in advance what is a process is. A process is the systematic method of activities, various tasks that are performed. Okay. Method, sequence of systematic activities, that is process. So in the process planning, what we do, uh, we s- we plan for the process that should be used in the project. Okay, so that means specifying the various stages in the process, the entry criteria for each stage, exit criteria for each stage, and the verification activities that should be done at the end of every stage. So these are the things that we should do during this process planning. Okay, so there is a life cycle of planning for the planning for the process. Okay, and the next activity is effort estimation. This is yet another planning project planning activity, effort estimation. Uh, So, for a given set of requirements, it is desirable to know how much it will cost to develop the software and how much of time the development will take. All these things should be known, which we will try to estimate. Okay, these estimates are needed before the development is initiated for us. Okay, the primary reason for cost and schedule estimation is for the cost benefit analysis and project monitoring and control. So that's why we need them. Okay. So yet another use of this estimate is for the bidding for a software project. Okay, when the project is given as a contract, then at the time of bidding, these estimates are useful. Okay, the bulk of the cost of software development is due to the human resources. Okay, needed for the development, and therefore the most cost estimation procedures is focus on effort in terms of person per month. Okay, uh, how many staffs are needed. Okay, so in the software development, the raw material is mostly the effort of the staff. How much of staffs are needed, their salary and their efficiency. These things are there. So staff estimation is one of the major issue in the effort estimation. Okay. So by properly including the overheads like cost of hardware, software, office space, and efforts and others in the cost of the project, effort estimation can be converted into the actual cost that the software will consume. Okay. There are two types of estimation, namely top-down estimation and bottom-up estimation. Okay, top-down estimation and bottom-up estimation. Okay, in the top-down estimation model, if the size estimation is inaccurate, the effort estimation produced by the module will also be inaccurate. It will not be correct. Okay, so it is important that the good estimates for the size of the software be obtained from the project analysis team. Okay, so there is no simple method, no specific method is there for estimating the size of the project. Okay, so some of the steps, that some of the way we perform this top-down estimation are given here. There are some several steps are there. The first step is identify modules in the system and classify them as simple, medium, and complex. Okay, this is first step in the bottom-up approach. Okay, then determine the average coding effort for simple, medium, and complex modules. Okay, then uh, get the total coding effort using the coding effort of the different types of modules. different type of modules and the counts for them. Okay, that is get the total coding effort. And the next one is using the effort distribution for similar projects. Estimate the effort for other tasks and the total effort. Okay. The next step is refine the estimates based on project specific factors. Okay, so these are the 5 steps that we follow for the bottom up estimation of a project. Okay, so identify the programs in the system and classify them as identify programs or modules. So classify them as simple and medium and complex. Define the coding effort for these simple, medium, and complex modules. Get the total coding effort. Use the effort distribution in similar projects that we have performed already to estimate the effort for other tasks. Okay, and refine the estimates. Okay, these are the approach followed in the bottom-up approach. One example of this bottom-up approach, it's a top-down approach. Top-down approach is a COCOMO model. COCOMO, constructive cost model. Constructive cost model. Okay, it is a top-down approach. The basic steps that we do in the COCOMO model are: number one, obtain an initial estimate of the development effort from the estimate of thousands of delivered lines of source coding, KLOC. Okay, so obtain the initial estimate size using that means the get a initial estimate of the development effort from the estimate of the thousands of lines, thousands of delivered lines of source coding. The next step is The second step is determine a set of 15 multiplying factors, okay, from different attributes of the project. And the third one is adjust the effort estimate by multiplying the initial estimate with the multiplying factors. Final multiplying factor. These are the 3 steps that we perform already. Okay. Okay, come let us see all these things one by one. The initial estimate, otherwise you call that as a nominal estimate, is determined by an equation of the form. What is that equation? E is equal to K into KLOC to the power B. E is equal to A into size means thousands of lines of coding to the power B. Okay, this is the equation. Effort estimation is initial effort estimation E is equal to A multiplied with the size of the project to the power B. Now you might wonder what is this A and B. The value of these constants A and B depends on the project type. Okay. In COCOMO, every project is categorized into 3 types, namely organic, semi-detached, and embedded. These are the 3 types of 3 ways in which the COCOMO model is projects are classified. Okay. For the organic type of project, the value of this A and the value of this B is 3.2 and 1.05. 3.2 and 1.05. And for the semi-detached project, the value of this A and B are 3.0 and 1.12. And for embedded type of projects, the value of this A and B is 2.8 and 1.20. 2.8 and 1.20. So in the constructive cost model of effort estimation, The projects are divided into three categories, namely organic model, semi-detached model, and embedded model. We have to perform some initial effort estimation using the formula A into size to the power B. And for this organic model, semi-detached model, embedded model, the values of A and B are varying, changing. Values of A, B 3.2, 3.0, and 2.8 respectively. And the value of this B is 1.05, 1.12, and 1.20 respectively. There are some 15 cost derivatives, cost driver attributes are used for effort estimation. All these cost drivers, they are classified into four categories, namely product attributes, computer attributes, personal attributes, and project attributes. Project attributes. Okay. So, what are these 15 cost drivers? They are namely required reliability, database size, product complexity, execution time constraint, main storage constraint, virtual machine volatility, computer turnaround time, and analyst capability, application experience, programmer capability, virtual machine experience, and project language experience, programming language experience, then modern programming practices, and the use of software tools, and the development schedule. So these are the cost drivers that are used to get the initial effort estimation on the COCOMO model. So we have a complex equation. The values of this cost drivers are used to evaluate the initial uh, effort estimation. Okay. So the next activity is scheduling and staffing. We have to plan for our scheduling and staffing. Okay. See, in a software project, the scheduling activity can be broken into two sub activities, namely determining the overall schedule with major milestones, and developing the detailed schedule for the various tasks. Developing the detailed schedule. Okay. So two activities in the project scheduling activity are determining the overall schedule, developing the detailed schedule. These are the two things. Okay, we see them one by one. Okay, so in the to determine the overall schedules, what we do is, see, this effort estimation for the project depends on this overall scheduling depends on the effort estimation that we have obtained. Okay. Uh, so there is a formula uh, to find the effort estimation as well. Okay. one method to determine the nominal overall schedule is to determine it as a function of efforts. Okay. Uh, any such function has to be determined from the data from completed projects using some statistical methods like regression curves and everything. Okay. See, you should know that the scheduling is not a function solely on the effort alone. Okay, so the scheduling determined is not really fixed, but it can be used as a guidelines or check for later activities. Okay, detailed scheduling. Okay, this is the second activity in the scheduling, overall scheduling. Okay, for detailed schedule, the major tasks fixed while planning the milestones are broken into smaller sub-schedule activities in a hierarchical manner. Okay, for example, the detailed design phase can be broken into tasks for developing the detailed design for each module, review of each detailed design, fixing of defects found, and etc. Okay, at each level of refinement, the project manager should determine the effort for the overall task from the detailed schedule and check it against the effort estimation. Okay, and if this detailed scheduling is not consistent with the overall schedule and effort estimation, the detailed schedule must be changed. Okay, and also if it is found that the best detailed schedule cannot match with the milestone effort and schedule, then the earlier estimates must be reviewed. Okay, then only you can do that. Okay, so one thing you should know that a detailed project schedule is never a static thing. It is a detailed thing, a dynamic one. Changes may be needed because the actual progress in the project may be different from what was planned, because newer tasks are added in response to change requests or because other unforeseen situations. Okay, so changes are done as and when the need occurs. Okay, so the rest of the things we will discuss in the next class. Okay.